Hi guys, welcome to Learn at Home. I'm Siddharth and today we're gonna understand about pressure measurement part 2. If you are a Hindi listener, you can click the link below in the description and you can get the Hindi video too. Now just move on to our pressure measurement part 2. Why it is part 2? Because I have already made part 1. As I have told you in previous video, I have classified our pressure measurement devices in 5 different categories and we are going to understand every single category in single lesson. So that's why I have made the videos in 5 different sessions. This is my second session, so it is pressure measurement part 2. In this session, we are going to talk about mechanical pressure measurement devices such as Bourdon tube, elastic diaphragm, corrugated diaphragms, capsules, bellows, or deadweight testers. So just move on to our lesson. First thing is, what is mechanical pressure measurement? Mechanical manometers provide faster response than liquid column manometers. Why? Because as we told you, in liquid column manometers there is a lag due to the displacement of the liquid. We can classify our mechanical pressure sensors like Bourdon tubes, diaphragm, bellows, or capsules. We are going to talk about all these 4 types in our lesson. First one is Bourdon tube. What is the Bourdon tube? Bourdon tube is the oldest pressure sensing element. In Bourdon tube there is a length of metal tube of elliptical cross section and shaped into letter C. As you can understand, it is a metallic tube which is shaped in English letter C and its dia is elliptical. How does it work? The basic principle behind the Bourdon tube. When an elastic transducer like Bourdon tube is subjected to a pressure, it deflects. This deflection is proportional to applied pressure when calibrated. This is the principle. Now just move on to our Bourdon tube gauge. If you want to understand a Bourdon tube sensor, you have to just learn about a simple construction of gauge by this Bourdon tube. In this image you can see here is a Bourdon tube type gauge. In this, here is our Bourdon tube and that is connected with the link and sector or pinion, and this full assembly is called a gauge. Now just talk about its construction. It had a graduated scale, pointer, pinion, linkage, sector, small socket or Bourdon tube and Bourdon tube. You can see all these parts in this image. As you can see, this is our Bourdon tube which is in C shape, and its cross-sectional area you can see in this image here. Now this is a real view of a gauge, Bourdon tube gauge. Here this is a Bourdon tube. This is in a springy form, but normally it is in a C shape. Let's just talk about Bourdon tube pressure gauge. The main parts of this instruments are follows: an elastic transducer, in that is a Bourdon tube which is fixed and open at one end. As you can see in this image, this end is fixed and this end is open. In this end we can apply pressure and this end is free to move. So when we apply a pressure on this end, as you can see, it is a metallic tube and its tendency to take a circular cross-sectional area. So while the pressure, this free end moves towards up direction, and when it moves towards up direction, the link with the help of sector gear, it moves the pinion, and when the pinion moves, it rotates the pointer on the scale, and it is proportional to our given pressure. So we can see the pressure on the scale by the pointer by this assembly. So this all construction is called Bourdon tube pressure gauge. If you want to learn in detailed description, you can pause the video and learn all this and read all this. This is written by me. So now let's talk about Bourdon tube pressure gauge. Mm, why, what is the application of Bourdon tube pressure gauge? Normally Bourdon tube pressure gauge is used to measure the medium pressure and high pressure. As we talked in our previous video, the low pressure can be measured by manometers or micromanometers. There are many types of manometers. So what is the advantages of Bourdon tube pressure gauge? The Bourdon tube pressure gauge gives an accurate result, so it is precise. So the Bourdon tube cost is low. Bourdon tubes are simple and simple in construction, sorry. They can be modified to give an electrical output. So as you can understand, this is a mechanical assembly, so we can convert it to give an output in electrical form. So just add some mechanical stuff, more mechanical stuff, and you can get an electrical output. Like you can attach LVDT and you can get an electrical output. So they can be modified to give an electrical output. They are safe even for high pressure measurement, because this is a closed mechanical system where when we apply a pressure, the all pressure is exerted to Bourdon tube, so it is safe from any hazardous situation. So the next is accuracy is high, especially at high pressure. So its accuracy is high, so this is the main advantage of Bourdon tube. Limitation of Bourdon tubes: they respond slowly in to change in pressure. As we can see, when we apply the pressure on the Bourdon tube, it mechanically rotate the sector and pinion all the system, so it is slow in response. So the response time is slow. They are subjected to hysteresis. As you can understand, it's right direction and left direction is different, because some of the reason of mechanical assembly. So it can also subjected to hysteresis. They are sensitive to shock and vibration. As you can see, this is a mechanical assembly, and this is sensing the pinion and sectors, all the parts are very sensitive to vibration. If the vibration happen or the pressure exerts any shock on this, it can deflect the pointer also, so it is very sensitive to shock and vibration also. Amplification is must, as the displacement of the free end of the Bourdon tube is low. As you can understand, the Bourdon tube move very small, in a very small quantity, so we have to amplify the movement of Bourdon tube by the assembly of sac, pinion and all these things. By that, so this Bourdon tube needs a mechanical system to amplify its motion. It can be used for the it cannot be used for precision measurement. As you can see, it is lag in time, lag in response, and it needs amplification, so it cannot be used in precision measurement. The second one is elastic diaphragms. So what is elastic diaphragms? Actually, the diaphragm is an elastic device, or it can be a metallic device also. So when we apply a pressure, it deforms, and when it deforms, its deformation is directly proportional to the applied pressure. So it can be a metallic or non-metallic. In metallic type, the metallic diaphragm have a spring quality. When we apply pressure, metal deforms, and when we exert when we remove the pressure, and the metal will get their original shape. If it is non-metallic, it can be elastic when we stretch it and when we release it. All you can understand by this. Now let's talk about a Bourdon diaphragm gauge. How can we make a diaphragm uh, sensor to a diaphragm gauge? We can make, as we can understand, in every starting point, so that the sensors are Bourdon tube diaphragms. Every sensor can make a gauge. That's why we are using it. So by diaphragm, we can fix its corners, and we apply a pressure, and the output will be exerted, and we can make an mechanical assembly by pinion and link sector, pinion, all these parts, and we can rotate the pointer also. If we want an electrical output, we can use the diaphragm, and with the help of a capacitor, we can make a capacitor with this diaphragm, and when the diaphragm deflects, the capacitance will change, and we can get an electrical output also. And we can make any resistive or inductive type output also from this. So just talk about applications of this elastic diaphragm gauge. They are used to measure the medium pressure, but they can also be used to measure low pressure including vacuum. They are used to measure draft in chimneys of boilers. Now let's talk about advantages of elastic diaphragm gauges. Best advantages is they cost less, they have a linear scale for a wide range, they can withstand overpressure, and hence they are safe to be used. No permanent zero shift. They can measure both absolute and gauge pressure, that is differential pressure. Now let's talk about limitation of elastic diaphragm gauges. Shock and vibration affects their performance, and hence they are to be protected. As you can understand, when the shock is applied or a vibration is applied, the diaphragm is also deformed, so the output can be affected. So we have to protect it from the vibration or shock. When used for high pressure measurement, the diaphragm gets damaged. These gauges are difficult to be repaired. As you can understand, this is a metallic or a elastic, so when we apply a higher pressure, a higher value of pressure, uh, the diaphragm is ruptured, so the output affected, and it's very costly to repair. So we normally use diaphragm type gauges for medium type pressure. And now here is a note about diaphragm materials. Let's read it. Metals, stainless steel, inconel, monel, nickel, and beryllium copper is used for metallic diaphragms. For non-metals, nylons, teflons, and buna and rubber is also used for non-metallic diaphragms. When we move to capsule or bellows, you can understand why the figure. Here is left side, it is a capsule, and this right side is a bellow. When we apply a pressure on a diaphragm, it deflects, and by this we can measure the pressure. In capsule, there is two diaphragms is merged in a one, so we can amplify the deflection by it. Here you can see here is two corrugated diaphragms, one is upper and one is lower, both are connected and joined. When we apply on the pressure, the corrugated diaphragm, as we can increase the area, the output will be absolutely high. So we can make capsules and bellow, and amplify the output of pressure. So it is also a form of a diaphragm, but you can see it is different in looks. So you can understand, when we apply any pressure, it deflects, and this deflection is proportional to our pressure. Now let's talk about our fourth and deadweight tester. This is also a mechanical pressure measurement device. This is mainly used for calibration. So it is used for all type of gauges. It is used for calibrating all type of gauges. It is very precise in output. So let's just talk about this. As you can see in this image, actually this is a real deadweight tester. Actually this is a Bourdon deadweight tester, you can see. And in this image you can see it is a diagram which shows what happening in this deadweight tester. As you can see, here is a valve, and this is a test gauge which is going to calibrated by this all instrument. And here is weights. This is a limiter stop, and this is a cylinder. This is a piston, platform, handle, all the system you can see, all the arrangement you can see. Now let's talk about this deadweight tester. This deadweight tester is based on a Pascal law. And now what is the Pascal law? When we use a incompressible fluid in a closed system and apply a pressure on this and pressurize this fluid, it exerted force on every direction with the same intensity. Okay, so in this deadweight tester, here is the oil that is filled in this closed system. Here is a piston to compress this liquid and two ports, this piston and this valve. We can get the output pressure of this fluid, but both are same because of this Pascal law. So in first situation, we close the valve and put some weight on it and pressurize with this handle until this piston goes free and reach the limit stop value. On this value, we read the weight and calculate the output because this weight is proportional to the pressure applied. Okay, so we get the output pressure P, how much pressure applied to hide this weight. Now we connect our test gauge and open the valve and put the weight again on the platform. Now the piston is not moving, so the weight, when we apply the weight, it exerts same pressure as the previously we applied with the handle. So the pressure output is exerted on every direction with same force. So the pressure P is also applied to this gauge and we can read this from its pointer. If the value of P and this output pressure of this gauge is right. If it is different, we change the gauge value and correct the gauge value with the help of first our pressure P. So it is a very precise instrument. As you understand with all these pressures how we calibrate the gauge. Now for the next chapter, pressure measurement part 3, keep watching our channel and the link is given in the description below. You can see the video from there also. So please keep watching and do subscribe, like and share our videos for promotion. Keep watching Learn at Home. Thank you so much.